So now I'm covering section 3.1, which is about functions. So you can go through the definitions of functions in the textbook or in the handout. So the function means for every x, there is a unique y, and the set of all x are called, set of all x are called the domain, is the domain, and the set of all the y values are called the range. So these are the basic definition of the range and the domain. So here, if you look at that, the domain is, if you write down the domain, all the x values, -1, 2, 4, 9, and 11. And the range, if you write the range, 1, 8, 2, -8, and -3. So here the question is, we have to check if the given this is called the relation. I'm going to check if this is a function or not. To check that one, all we need to do is check if all the x is unique. If any of the x repeats or duplicates, then it's not a function. Here I have -1, -2, 4, 9, 11. There's none of the x is repeated here, so it is a function. And you have to remember one more thing. If the y repeats, it doesn't matter. Okay, only the x cannot be repeated. And the second problem is a square root function, y equals 6x minus 3. Again, you can use the graphing calculator to check. However, for each x, you're going to get only a unique y. You can plug in different values for x. You're going to get only unique value for y. So the x doesn't repeat here. So it is a function. And number 3, we are going to state the domain of the function. So the function is y equals square root of 15 minus x. And as I mentioned before, the domain is set of all x values. So here I can give any x for we are going to check if we can give any x for this function. However, remember that this is the square root function. For square root function, we cannot have negative values inside the square root. What that means is we have to set this quantity inside the square root that needs to be positive. In other words, if you write in it's mathematically, this expression should be greater than or equal to 0. So now we have to get the x by itself, and that is going to give our domain. So first, let's move the 15 to the other side. Let's get the x by itself. So we get -x is greater than or equal to -15. And we have to have the positive x. So you divide both sides by -1. Remember, when you divide by -1, I have to flip the inequality. Okay, so that becomes x is less than or equal to positive 15. So now we have the domain is all the numbers less than or equal to 15. So we can write this one. So what that means is, like, if I have 0, 15 here, all the numbers less than or equal to, so we learn how to graph. So it's going to be all the numbers including 15. So it's a square bracket. Okay. So the domain is going to be, this is the graph of this inequality, and we can write in an interval notation as negative infinity to positive 15. The next example, we have f of x equal to 1 over x plus 6. So just like the previous example, we have square root in the previous example. So we cannot have negative inside the square root. The same thing when you have the similar to that when you solve a fractions or rational function. This is called a rational function. We cannot have 0 in the denominator. So when you are solving for a domain or when you are identifying the domain of this rational function, you have to set the denominator not equal to 0. That means x plus 6 cannot be equal to 0, or when you solve for x, x cannot be equal to negative 6. So what that means is the domain is going to be all real numbers except negative 6. So how do I write as an interval? So all the numbers negative infinity to negative 6. See, I'm putting open bracket, that means negative 6 is not included, and from negative 6 to positive infinity. So this is how we write the interval notation. Next, problem number 5. We are going to evaluate the function. What that means is we are given a function and we are given a number, and we have to plug it inside the function for all the x values. So we are going to find f of negative 3. So you plug in negative 3 for all the x in the function. So we get f of negative 3. Negative 3 plus 5 is 2. So it's going to be square root of 2. You can use your calculator and you can round the number. It's going to be 1.4142. Number 6, we are going to find f of k for f of x equal to 3x squared plus 4x plus 5. Note here, we are not given a number. We are given a letter or a variable. So we're going to plug in k for all the x in this function. Wherever x comes, replace that x by k. And we have square here. So what is f of k is going to be now? So 3k squared plus 4k plus 5. And number 7, we have to find f of x equals 3 minus 8x to the third, and we are finding f of negative n. So we are replacing all the n by x by n. So we get f of n equals 3 minus 8n to the power 3. Okay, so we did all this 6 and 7 example because we are going to find difference of quotient. So this is called, this expression f of x plus h minus f of x all over h. This is called difference of quotient. We use this one more in calculus, but here we are just learning the basic. So for the function f of x equal to 9x minus 3, this is what is given. So we have to find f of x plus h minus f of x over h. So first we are going to go step by step. First we are going to find, so step 1, find f of x plus h. We can do step by step. So what that means, we are going to replace all the x by x plus h in f of x, which is given as 9x minus 3. So we're going to find, so I'm going to keep this one open. I'm going to plug in x plus h here and x plus h here. So we get f of x plus h equals, now distribute the 9, so we get 9x plus 9h minus 3. So there is no terms to group, so we don't have to worry about that. Step 2, we are going to find f of x plus h minus f of x. So let's first f of x plus h minus f of x. So from the previous step, we got f of x plus h, so I'm plugging in that one for f of x plus h minus f of x is 9x minus 3. So now we have to, let's remove the brackets. The first one is positive. The second one is minus, so you have to distribute the minus sign here. So we get 2 terms. What happens now? This 9x, 3 gets cancelled. So we just get 9h. Now step number 3, we are going to find f of x plus h minus f of x all over h, which is from the previous step, f of x plus h minus f of x is 9h, and divide by h, so we get just 9. So the next one, same thing. We are given f of x equals x squared minus 4x. We have to find the same thing. So first, step 1, we have to find f of x plus h. So that means you take the function f of x, which is x squared minus 4x. Now we are going to replace all the x in this f of x by x plus h. So we know that x plus h square means x plus h times x plus h minus 4 times x plus h. So now we are going to use the FOIL to expand this. So we get x squared plus hx plus hx, hxh or xh, both are same, and distribute the negative minus 4x minus 4h. So we have to combine the like terms. These two are like terms here. So we get 2xh plus h squared minus 4x minus 4h. So this is our f of x plus h. Step number 2. So this problem is going to be a little longer than the previous one. So again, we are going to find f of x plus h minus f of x. Okay. So from previous step, we have f of x plus h. Get the f of x plus h from the previous step, which is x squared plus 2hx plus h squared minus 4x minus 4h. So this is only for f of x plus h minus, right? F of x is x squared minus 4x. So we get to, let's remove the brackets now, minus 4x minus 4h. And then when you distribute, this is going to be negative x squared, and this is going to be positive. I'm aligning the like terms so we can group the like terms. Okay, so these two get canceled. So I get f of x plus h minus f of x is going to be 2hx plus h squared minus 4h. Next, we are going to find the difference of quotient. So step 3, find f of x plus h minus f of x all over h. So from the previous problem, previous step, we have f of x plus h minus f of x is going to be 2hx plus h squared minus 4h, and everything divided by h. So we're going to simplify this by dividing each term in the numerator by h in the denominator. So we get 2x plus, so 1, we get just h minus 4. So this is our final answer. And the last problem in this section, number 10, it's a word problem. If a rock is thrown vertically upward from the surface of the moon at a speed of 21 meters per second, its height after t seconds will be s of t equals. So I'm just writing the expression. You can look at the handout for the problem. So this is the s of t given. We have to find its height after t seconds. And that, so t is given as 6 seconds. So plug in 6 for t, both sides, and then use your calculator to get the answer. So I'm plugging in 6. So I get, when I used my calculator, I got 97.2 meters. So that is end of section 3.1.